everyone, welcome to this master class. So guys, today we will be continuing the 15-day sprint to JEE Main, the ultimate countdown. So as you all are aware, in this series we will be looking at the most probable questions that might appear in your exam this January. Okay guys, so every day we have 3 sessions: physics, chemistry and maths. Physics is at 7, chemistry is at 8 and math is at 9. Okay guys, so yesterday we saw the topic set, relation and mathematical reasoning and then statistics. So we will continue further and move into algebra now. Okay, so today's class, let us start off with algebra 1. So what is algebra 1? Algebra is a big chapter, right? So I broke it down into 3 parts. Algebra 1 today, algebra 2 we will have a look at it tomorrow, and then the day after I will continue with algebra 3. Is that okay guys? So what is algebra 1? In algebra 1 I am going to discuss about quadratic equation, complex numbers and sequence and series. And I am sure most of you like these 3 chapters because they are quite easy and quite interesting as well. And I have brought some really good questions today which we will look at in a while. Okay guys? So before we get started, for those who don't know me, my name is Shimon Joseph and I am a master teacher at Vedantu. I have been teaching for almost 6 years now. And like you guys, I too prepared for JEE Mains few years back, and when I took it I was one of the state toppers and I am a KVPY scholar as well. Okay, so that is a quick introduction. With that, let us dive right in. But before that, as we always do, we analyze the previous year's papers. Let us quickly have a look at that. What is here? So this is an analysis guys of the previous year's papers. To be precise, the last 5 years, because that makes more sense, right? Because the last 5 years we have had JEE Mains. So in that, if you look at it, algebra has the highest weightage. Algebra is going to be highest weightage, which is almost like 9 questions. You get 9 questions solely from algebra. Isn't that super amazing? So that is exactly what we'll be looking at, so that you guys have an idea how important this topic is going to be, so that you can plan your schedule accordingly in the last 15 days. Okay guys, so we will get into the questions for today. The first one is right on your screen. Okay, so what is given here? There are 2 quadratic equations and they have a common root. Then they are asking you what is A and what is B. Now how do we go about solving this? So the concept behind this question is common roots. As soon as I read the question, I understand that. So the concept behind this question is common root, and which chapter is it under? It is under quadratic equations. Okay, so I am comfortable with this concept. I know that if it is a common root, then it has to satisfy both of them. Okay, so that is the concept of common root. Now let me try to solve it. Okay guys, now let us check the roots of this. Why? Because everything is given, right? Here A, B and C are given. All the coefficients are given. So can I find the root of my quadratic equation here? Yes, absolutely, because I can apply the quadratic formula. So what are my roots? My roots are going to be x is equal to minus b plus or minus square root of b square 49 minus 4ac. What is 4ac? 4ac is going to be 8 by 2a. Is that correct? Is that correct guys? So this minus b plus or minus root of b square minus 4ac. So that should be right. So what do we have here? This is an important clue. You have a very important clue over here. What is that? Here you have irrational roots, because what is 49 minus 49 minus 8? 49 minus 8 is nothing but 41, and root of 41 is not a integer. The root of 41 is not an integer because 41 is not a perfect square. 41 is not a perfect square. Therefore, I cannot further simplify it. So my roots are going to be x is equal to 7 plus or minus square root of 41 by 4. Okay, so that is my root. Now, if one root is common, let's say 7 plus root 41 by 4 is common. Don't you think the other root also will be common? Because they are irrational roots. They are irrational roots. That is it guys. So what is the condition for this? Both the roots are going to be common. Why sir? Because if one root is irrational, then we know a property, right? Irrational roots occur in pairs. and moreover my A, B and C are all real numbers. So if they occur, if an irrational root occurs, then it is obviously going to occur in pairs. So if I say 7 plus root 41 is a root of this, if I say one of them is a root of this, because they have a common root, right? If one of them is a root of this equation, then the other root also should be the other one here. Then the other root also should be the other one here. So what I am trying to say effectively is both the roots should be common between these two equations. That's it. Done. Both the roots should be common. So what is the condition for both roots being common? We will write that down now. We will write that down. So it is a laddu question, guys. It's a very simple question. I am sure all of you are able to follow. So please revise the properties, because quadratic equation, complex numbers have a lot of properties associated with them. So that is exactly what I am trying to focus on right now. And I am sure most of you know that if in a quadratic equation ax square plus bx plus c, if I have imaginary root, if I have one imaginary root and a, b and c are real, a, b and c are all real numbers, then what can I say? Can I say that the other root also will be imaginary? Are you all aware of that? So that is a similar property which I am trying to use over here. Is that okay? So irrational roots also occur in pairs, similar to what we know in imaginary roots. I am sure imaginary roots people must have come across in questions. Imaginary roots occur in pairs, but there is a condition. There is a condition. What is the condition? A, B and C are belonging to real numbers. Without that you cannot apply it blindly. Okay guys? So imaginary roots occur in pairs only if this condition is satisfied. Okay? With that we will solve this question. So now both roots are common. So let me erase it. Okay. So now given that both roots are common, what is the condition now? So either they must be the same quadratic equation. It should be 2 minus 7. But wait a minute. Is 1 and 2 matching? No. So they cannot be the same. But what can they be so that both the roots are common? They can be proportional. So what do you mean by that? 2 by A is equal to minus 7 by B is equal to 1 by 2. Is that correct? Yeah, perfect. So what is A? A is equal to 4. And what is my B? B is equal to minus 14. So is there an option like that? Yup, there is. So option C is my right answer. Is that clear to everyone? So that is how you solve this question, guys. I hope all of you liked it. It's a basic question again. Yes, totally basic. But the property is more important. I guess now everyone is clear about it. So we will move on to the next question. Okay guys? Perfect. So the next question which we have is right over here. Again, another question on quadratic equation. Now, what is given here? Here, p is greater than 0. For p greater than 0, and this is my quadratic equation. What is my quadratic equation? My quadratic equation is 3x square plus px plus 3 equal to 0. Now, what are they saying about this quadratic equation? They are saying that one root of this equation is square of the other. That means if I say alpha is one root, then what is the other root? The other root is alpha square. That's it, over. Okay. Now another very important concept in quadratic equation, which is sum of root and product of roots. Guys, sum of roots and product of roots finds a lot of use in questions on quadratic equations. So please be very proficient in solving such questions. Okay. So now let us see what is sum of root alpha plus alpha cube. Alpha plus alpha square. Okay. So alpha plus alpha square, this is sum of roots, right? These are the two roots and I am adding them up. I know what is sum of roots. It is minus b by a. So let me do that. What is minus b by a? It is minus p by 3. And what is product of roots? The product of roots is nothing but alpha into alpha square. And how much is that? Alpha cube. And how much is that going to be equal to? C by A. What is C by A? It is 3 by 3. And what is 3 by 3? 3 by 3 is 1. But guys, something amazing happened here. Alpha cube is equal to 1. I can get alpha directly. I can get alpha directly. So what is alpha? Alpha can be 1 or omega square. Isn't that correct? Alpha can be 1 or omega square. Why is that? Because this is nothing but cube root of unity. So they have mixed the concept. Can you visualize that? That is super amazing. They are mixing two different chapters in a very good manner. Okay. So alpha cube is equal to 1. That means alpha is 1 omega and omega square. Now let me take one by one. If alpha is 1, let me substitute here. So what is alpha? Alpha is 1. So 1 plus 1 is equal to minus p by 3. So what is p equal to? P equal to minus 6. But can p be negative? Can p be negative? Guys, think about it. What are they given here? Can you all see this? Yup. So p is greater than 0. If p is greater than 0, what I got here is saying something else. So can alpha be 1? No. For this question, alpha cannot be 1. Super awesome, right? Good. So now I can erase this off. So because alpha cannot be 1, and I can erase this also, because I just proved p cannot be minus 6, because they have given it clearly in the first step that p should be greater than 0. Okay guys, so now it asks you either one of these, and either one of these does not make a difference, because see the expression here. If I put omega, it will be omega plus omega square. If I put omega square, it will be omega square plus omega power 4, which is again the same. So it can take either one of these, and both are fine. Both are fine. So let me take one of them. Let's say alpha is equal to omega. So if alpha is equal to omega, what will I get? Omega plus omega square is equal to minus p by 3. Omega plus omega square is equal to minus p by 3. And what is omega plus omega square? Do you guys remember? Do you all remember this? Do you all remember this? Okay, so what is omega plus omega square? Omega plus omega square is equal to minus 1. So this is minus 1. So minus 1 is equal to minus p by 3. And what is p? P should be equal to 3. Is that fine now? Yes. Now that is fine for me, because it is greater than 0, right? Here what do we have? We have p greater than 0, and therefore this answer which I got now is perfectly fine. Good? Did you all understand? Perfect guys, good job. So that will be my answer, and let's check it. I think it should be, yeah, hopefully it should be that. So that is the answer for this question. Super awesome. So now we will move to the next one. I hope all of you have understood. Guys, if you did not get it, please rewind it later on and look at it slowly, because these are all good concepts. It's better to take time and understand them. Okay, so let's go to the next question quickly. Now we are moving on to complex numbers. Okay, we are slowly moving on to complex numbers. So if you want to try it out, please pause your video and do try it out. I would like that. I would like you guys to solve it on your own and check whether you are getting the same as me, and whether your approach is shorter. And if you have a much shorter approach, please do let me know in comments. I'll be more than happy to learn from you guys as well. Okay? So guys, let us try to see how this question is solved over here. So now, if you have solved complex numbers a lot, you would know that these quantities inside are nothing but omega and omega square. These quantities inside are nothing but omega and omega square. Sir, I don't know, sir. I have never solved complex numbers my entire life. How do I find it out? Okay, so let us try to do it. How do I figure it out when I don't know what is the actual representation or reduction of this inside quantity? Okay. So now, what is cube root of unity? Cube root of unity comes from omega and omega square. How do they come from, guys? Let us derive it quickly. Okay, it's quite easy. So I will take this 1 to the other side. I will write it as x cube minus 1 equal to 0. Now I will write it as x cube minus 1 cube. Why? Because x cube and 1 cube, 1 and 1 cube are the same. 1 and 1 cube are the same. Now I can factorize this, right? How do I factorize this? X minus 1 times of x square plus x plus 1 equal to 0. Okay, I hope that's clear. Somewhat? Yeah. Okay, so now, okay, let me erase it. So now, these are the roots of x cube equal to 1. These are the roots of x cube equal to 1. So what are the roots? X equal to 1 is a direct root because this can be 0. Now, where do the other two roots come from? We just know that it is omega and omega square. But how do they come from? They come from this expression over here. They come from x square plus x plus 1 because it's a quadratic equation, right? So quadratic equation have two roots. It has two roots. So those two roots, omega and omega square, are effectively coming from here. So what are they? Omega and omega square are nothing but minus b plus or minus square root of b square minus 4ac by 2a. So what is omega and omega square? Omega and omega square are nothing but minus 1 plus or minus root 3i by 2. Okay, minus 1 plus or minus root 3i by 2. Did you all understand this? So I took that expression over here. I have an expression over here, right? From this I get omega and omega square. So now, can you relate with the question? Can you relate with the question? What I obtained there? So let's say omega is, let's say my omega is minus 1 plus root 3i by 2. So what will be omega square? Omega square will be minus 1 minus root 3i by 2. Okay? So because that's what I derived there. That should be totally fine. I guess everyone? Are you guys comfortable with this? Now let us get to actual solving. Can I erase this? Everyone comfortable with this, right? Good job guys. Brilliant. Okay. So let us see how to solve this. So now minus 1 plus root 3i by 2. Don't I have the same thing here? Don't I have the same thing here? So can I say this is omega? So omega power 6. Now this is omega square. The second term is omega square. As you can compare here. Just compare both of them. So omega square power 6. Omega square power 6 will be omega power 12. Omega power 12. Now this will be omega power 5 because this is nothing but omega. This term is nothing but omega. Okay. So that will be omega power 5. And the last term will be omega square because it is negative, right? Omega square to the power 5. What is omega square to the power 5? It is going to be omega power 10. Omega power 10. Now let me reduce it. Let me reduce it because I don't want to have such high powers. I want to bring it to 0, 1 or 2. Okay. So let us do that. What is omega power 6? It is 1. It is 1. And what is omega power 12? It is also 1. Okay. What is omega power 5? Omega power 5 is omega square. Because omega cycles in 3. Omega cycles in 3. Okay, with a period of 3. Because 1, omega power 1, omega power 2, omega power 3. Again it will be omega square, omega power 3. Again it will be omega square and omega power 3. Is that clear guys? So that is why I wrote it this way. Now what will be omega power 10? Can you guys guess it? Can you guys guess it? It is going to be omega power 1. Brilliant. That is the right answer. Now, what is 1 plus omega square? In the previous question, I wrote it down. Did you all watch that? 1 plus omega square is 0. Therefore, the answer for this question is 1. The answer for this question is 1. Okay. So, that will be option A. That will be option A. Is that good? Everyone? Comfortable? So, again, it's a very simple question. But it involves your understanding and matching of a different concept in complex number and bringing it and putting it here. Okay, so that is what I would like you guys to practice on. You have to be able to match the concept. You have to quickly do that and then immediately bring it over here. Okay, so I hope it is clear. We will move on to the next question that I have for all of you. Let us get started. Okay, perfect. Okay, yup, we have it here. So please try to solve this question guys. This is another interesting question again from the topic complex numbers. Brilliant question. Try to do it. Not very difficult, I would say, but for a mains question, it's a good representation. It's a good representation of the level of mains. Okay, so please try to solve it, and you can pause it right now if you want to, and I will start discussing right now. Okay guys, perfect. So now, what are they given here? They have said omega is a non-real complex cube root of unity. It is a non-real complex cube root of unity. That means what? It is omega and omega square. They are saying it is not 1, that's it. They are saying it is not 1, but it is imaginary part, that is omega and omega square. Now, as A and B belong to real numbers. Okay? And if omega and omega square are the roots of this equation over here, how, sir? If you simplify it, you will observe that it is a quadratic equation. If you simplify it, which I am going to do now, which I am going to do right now, you will observe that this is a quadratic equation. And how many roots does a quadratic equation have? Obviously it has 2 roots, right? So that is exactly what they have given here. Those 2 roots are given to you. So once you form the expression, it is going to be very simple to solve. Okay guys? So let's do that. So I am going to take the LCM, cross multiply, bring everything. I am going to make a quadratic equation. So that much you have to visualize before you even start solving. Before you even start solving, you have to go that much into it. Okay, so let's do that. What do we get? A plus B plus 2x by A plus x into B plus x is equal to 3 by x. Okay, so that is the basic simplification. Now let me directly write the quadratic equation. So when you simplify it, okay, let me do that for you. So it will be ax plus bx plus x square is equal to 3ab plus 3x square plus 3a plus bx. Is everyone clear with this? Did you all understand what I wrote here? I just multiplied it. I just cross multiplied both. Okay? I just cross multiplied both and I wrote it in a specific form. Okay? Now I bring everything to the right hand side. Everything I will take to that side. Okay? So can I erase this guys? Is that fine? I hope all of you are comfortable with this. If not, please pause it and note it down. I am going to erase it. Okay? Perfect. So now I will start from here. Okay? So let us erase this. Okay. Let us do it. Perfect. So now we have a lot of space to work. We will take everything to the right side. Okay? So when I take everything to the right side, what happens? You will get, I'm sorry, it should be 2x square. Yeah, it should be 2x square. Okay, that is the eraser. Plus 2x square. Okay, so now I'll take everything to the right hand side. So what will I have? X square, and then I will have plus 2 times of a plus b into x, and then what do I have? Plus 3ab is equal to 0. Okay, fine. So now let us come to the actual solving. This is the simplified version of this one. This equation is a simplified version of this one. So this equation has roots 1 omega and omega square. So this should also have omega and omega square as the roots. This also should have omega and omega square as the roots. Isn't that correct? Now let us come to actual solving. So if this has omega and omega square as the roots, then what is sum of roots? Sum of roots is minus b by a. Minus b by a. And what is this? Omega plus omega square. Omega plus omega square is how much? Guys, what is omega plus omega square? Any idea? It is going to be minus 1. So what is a plus b? A plus b is going to be 1 by 2. A plus b is going to be 1 by 2. That's simple. That's simple. You just directly apply the sum of roots concept and you're done. Okay, now how did I do this? Because omega plus omega square is equal to minus 1. No guys, we have been doing that in the first question, second question also. Wherein 1 plus omega square is equal to 0. So omega plus omega square will be minus 1. That's exactly what I wrote. So minus 1 minus 2, it will become 1 by 2. It will become 1 by 2. So that is my a plus b. So I will keep it in my mind. I will keep it in my mind. A plus b is 1 by 2. A plus b is 1 by 2. Now let that stay there. I will take the other one. What is the other one? Other one is obviously product of roots. Other one obviously is going to be product of roots. So product of roots is omega into omega square is equal to c by a. C by a. A is 1. Okay. So what is omega cube? Omega into omega square is omega cube. And what is omega cube? Omega cube is equal to 1. So omega cube is equal to 1. So what will be my product of AB? Product of AB will be 1 by 3. That's it. So product of roots I got, sum of roots I got. Now they are asking, then A and B are roots of which expression? A and B are roots of which expression? There are two ways you can solve this, guys. Either you can substitute. You can see which equation gives you sum of roots as 1 by 2 and product of the roots as 1 by 3. That is one way of doing it. One way of doing it. What is the other way of doing it? You can directly write the expression, right? You can directly write the expression, which I will help you with. I will help you with that. So when you know sum and product, how do you write the quadratic equation? X square, this is going to be x square minus sum of roots into x plus product of roots into 1, that is constant term, is equal to 0. That's exactly what I'll do. I'm sure all of you must have studied this formula. So this is how you write a quadratic equation when you know sum of roots and product of the roots. Is that okay, guys? When you know sum of roots and product of roots, you can directly write the quadratic equation. And this is how it goes. Okay. Now, what is my sum of root? X square minus 1 by 2 into x plus what is product of the roots? We got it to be 1 by 3, right? If I am not wrong. We got product of the roots to be 1 by 3. So I will write it as 1 by 3. Is that okay? Is that okay to everyone? Perfect, guys. So now this is going to be my quadratic equation. So let me simplify it. If I simplify it, it reduces to 6x square minus 3x plus 2 is equal to 0. What did I do here? I took the LCM which turns out to be 6. The LCM turns out to be 6 and then I simplify the quadratic equation. This is how it turns out to be. So what is the answer for this question? Anyone? The answer for this question is going to be option B. The answer for this question is going to be option B. Is that clear to everyone? Guys, are you all okay with this? Perfect? Good. So we will move on to the next question. I hope all of you are able to understand the concept behind this. Okay? So let us quickly move on to the next question which I have for you, and that is from sequence and series. So this is something interesting, guys. I recently came across this. It mixes the concepts of inverse trigonometry and sequence and series. So it's a good question to look out for. Okay. So now let me try to solve it. For you. So whenever a question like this is given, you have a series of n terms. Always try to write the nth term. What is the nth term? Nth term is nothing but they have given it, right? They have given it over here. So this is exactly my nth term. Now I will simplify it. 2 to the power n minus 1 by 1 plus 2 to the power n into 2 to the power n minus 1. Can I write it like that? Because 2 to the power n into 2 to the power n minus 1 is nothing but 2 to the power 2n minus 1. Is nothing but 2 to the power 2n minus 1. Isn't that right? Everyone? So because I can add the powers, right? Base is same, I add the powers. N plus 1 is going to be 2n minus 1. So that is nothing wrong in doing that. Now here comes the master stroke. 2 to the power n minus 1 can be written as 2 to the power n minus 2 to the power n minus 1. Sir, how sir? Take 2 to the power n minus 1 common. If I take 2 to the power n minus 1 common, what will be left out? 2 minus 1. And isn't that equal to 2 to the power n minus 1? Isn't that equal to 2 to the power n minus 1? So can I write it this way? Can I write it that way? Because it reduces the difficulty of a problem like anything. Okay. So this I will write it as 2 to the power n minus 2 to the power n minus 1. Okay. and I'm sorry, you have tan inverse outside. You have tan inverse on the outside. Okay. So now, why is this a very good reduction? We will visualize it now. Now guys, look at it. This is tan inverse of x minus y by 1 plus xy. It is of the form tan inverse of x minus y by 1 plus xy. And what is that? That is nothing but tan inverse of x minus tan inverse of y. That's it. So what is my nth term? My nth term is such a simple one. My nth term is such a simple one. That's it. So I will erase this. Okay. I will erase this. So now I have got a very nice nth term. So now I have to sum everything, right? I have to sum everything. What is Sn? Sn is equal to, Sn is equal to first term. What is first term? Tan inverse of 2 to the power 1 minus tan inverse of 2 to the power 0. So what is the second term? Plus tan inverse of 2 to the power 2 minus tan inverse of 2 to the power 1. What is third term? Plus tan inverse of 2 to the power 3 minus tan inverse of 2 to the power 2, and so on. What will be the nth term? Tan inverse of 2 to the power n minus tan inverse of 2 to the power n minus 1. Okay. So now when I add everything, what do you observe? This and this gets cancelled. This and this gets cancelled. So what is cancelling? Every other term is getting cancelled. The only two terms which will be left out, are going to be Sn is equal to tan inverse of 2 to the power n minus tan inverse of 1, because 2 to the power 0 is 1. 2 to the power 0 is going to be 1. That's it guys, as simple as that. So that is how you should solve questions based on this type. This type is very similar. You always write the nth term first. Write the nth term and then slowly work upon it. And then slowly work upon it, building your answer. Okay? So now, my question is not yet done because they are asking infinite terms. They are asking infinite terms. So my n tends to infinity. So my n tends to infinity. So if my n tends to infinity, so what will this be? 2 to the power infinity. 2 to the power infinity is going to be how much? That is 10. That is going to 10 to infinity, right? 2 to the power infinity is such a huge value. So it is going to 10 to infinity. So what is that going to be? Pi by 2 minus tan inverse of 1 is pi by 4. So what is my answer? What is my answer? My answer is pi by 4. Superb question. So you can expect something of this sort. Please be careful guys. Okay. You can expect a question of this sort in your exam. So please be ready for this. Okay. Such type of questions might come. So I hope now it is clear to everyone. If not, please go through it again slowly guys. You should be able to get the hang of it. Okay. So with that, let us quickly move on to the next question that I have for you, which is right on your screen. Okay. So here, definitely you may get a question from this topic, which is AM GM Inequality. AM GM Inequality has been finding its place in the JEE Mains question paper for the last 5 years. For the last 5 years, every single year there is one question from AM GM Inequality. So guys, this is a heavy weightage and high priority topic. You have to master this as well. So let us see how to solve this question. Okay. So definitely this is a AM GM Inequality question. Why? Because they are asking greatest value of a sum. They are asking greatest value of a product. Whenever they ask greatest value of a product or minimum value of a sum, whenever they ask greatest value of a product or minimum value of a sum, and then they give information like they are positive. That is an indirect clue. That you have to use AM GM Inequality. That's it. That is an indirect clue they are giving you. You have to use AM GM Inequality. And let us see how to solve this question. Okay. Let us see how to solve this question. So here we have 2x plus 3y is equal to 7. Now 2x plus 3y is equal to 7. I can split it in a different way. Can I write it like this? Is that fine? I just wrote 2x like this. You will understand it in a minute. You will understand it in a minute. The reason why I did this. I just wrote 2x as 2x by 3, 2x by 3, 2x by 3. I just split it into 3 parts. When I combine all of them, what do I get? I get 2x only. So this I wrote it this way. Okay. Now, can I write it this side? I will come that side. Okay. So I will write 3y as 3y by 4 plus 3y by 4 plus 3y by 4 and plus 3y by 4. Is that okay? So I am just adding everything. Now this entire expression put together is what? This entire expression put together is nothing but 2x plus 3y. The entire expression put together is 2x plus 3y. So now I will divide it by 7 because there are 7 terms. 1, 2, 3, 4, 5, 6, 7. So arithmetic mean is going to be sum of everything divided by total number of observations. Now that should be greater than or equal to my geometric mean. That AM, this is AM, right? AM should be greater than or equal to my GM. And what is my GM? My GM is going to be 2x by 3 whole to the power 3 into 3y by 4 whole to the power 4 to the entire power raised to 1 by 7. To the entire power raised to 1 by 7. I guess that is not clear. I may write it down again. I may have to write it down again. I'll write it over here, guys. I will write it over here. So it is greater than or equal to 2x by 3 whole cube into 3y by 4 whole power 4. The entire thing raised to 1 by 7. That is geometric mean. That is going to be geometric mean. Now do you guys realize why I wrote it like that? 2x by 3, 2x by 3, 2x by 3. Because when I write it split into 3 ways, then I am going to cube here. Then I am going to cube here. Why do I have to cube here? Because that is what is asked. That is what is asked. X cube y power 4. So depending on this, I have to bring x cube here, right? If I have to bring x cube here, then here I have to split it into 3 parts. Only if I split it into 3 parts, when I multiply 3, it will become x cube. Okay? So now, what is this? This entire expression is nothing but 2x plus 3y. The entire expression is 2x plus 3y. And what is 2x plus 3y? 2x plus 3y is equal to? And what is 7 by 7? 7 by 7 is equal to 1. That's it. As simple as that. Can you believe it? So such a complicated expression became very simple just by applying the right concept in the right way. Okay guys? So now it's not done yet. It's not done yet. So let me do it for you again. So 1 is greater than or equal to 2x by 3 the whole cube into 3y by 4 the whole power 4. Now 1 by 7 is there, right? This 1 by 7. I will raise it to the power 7 because my right hand side is also positive. My right hand side is also positive. So it will be 1 to the power 7 and this will become 1. Okay. I'm sorry, it will become 1. So this power will become 1 and this will become 7. What is 1 to the power 7? It is still 1 only. It is still 1 only. So now I will bring all the numbers to the left side. Okay. So what will happen? It will be 3 cube 4 power 4 by 2 cube into 3 power 4 is greater than or equal to x cube y power 4. Now simplify it. 4 power 4 is what? 4 power 4 is 256. Isn't that right? Yup, I think so. 256 is right. Divided by 8. 256 by 8 is how much? 32. So let me write that down. 256 by 8 is 32. And 3 cube 3 power 4. Okay, 3 cube and I have 3 power 4. 3 cube and 3 power 4 will cancel to give you 3. So the greatest value of x cube y power 4, the greatest value of x cube y power 4 is going to be 32 by 3. That's it. Over. The greatest value of x cube y power 4 is going to be 32 by 3. That is the answer for my question. Because see, x cube y power 4 is less than or equal to 32. So 32 by 3 is here. My x cube y power 4 is always less than that. So what is the highest value? The highest value can be 32 by 3. That's it. Is that fine? So that is how you get the answer for this question. I hope all of you are able to follow. So please try to solve some questions and master this concept today and right now, guys. Okay? So with that, we almost come to the end of this session. I think now we will focus on few important areas that you need to focus in the last lab. So guys, you are almost in the final stage of your preparation. You will need to really focus on certain areas that are high importance or high weightage. Okay? So what are those areas? In complex numbers, properties of modulus and argument is very important. Properties of modulus and argument is quite important. Please try to spend some time on that. And then there are questions constantly asked from cube roots of unity. As we saw just now, we saw a lot of questions based on cube roots of unity, right? So that is something which you have to pay attention to when you are preparing. Okay? And AM GM HM in sequence series is quite important because last 5 years, as I said already, you have every year a question from AM GM and HM. Okay? So predominantly it focuses on AM and GM, guys. Predominantly it focuses on AM and GM. So if you are good at AM and GM, you can crack that question with ease. Okay? And then we have series type questions wherein you are asked to calculate the sum of n terms or sum of infinite terms and so on. Okay? The last one is going to be quadratic equation. And as I discussed today, common roots is a important topic which people tend to dwell too much into, because a lot of competitive exams tend to focus on this particular topic a lot. Okay, and then as I said, the relation between sum and product, because this sum and product can be combined with other chapters. This sum and product can be combined with other chapters as well. As we saw today, they link complex numbers and quadratic equation together. That is a usual combination. So expect such questions, okay, and prepare for it accordingly, guys. So with that, we almost come to the end of this session, and before we leave, guys, I hope you enjoyed today's session, and if you did, please do give a like and subscribe to our channel. And in case you know some people who are not able to afford coaching, please do share these videos to them so that they can benefit from it. And the entire idea is to reach out to a lot of people who don't have access to good education. Okay, so thank you guys, thank you for being part of this session, and we will see in the next class in Algebra 2. Take care, bye bye. This is Shimon Joseph signing off.